Today's lesson is on properties of trapezoids. Again, we are dealing with another quadrilateral, which is a four-sided figure. The difference is that we've been working with parallelograms, which has two sets of parallel lines, and something that sets trapezoids apart is that they are quadrilaterals with one set of parallel lines. And our parallel lines, again, can be indicated by our tick marks that look like V's or arrows. So our parallel lines are what we call the bases. So this is a base, and this is a base. So there are two bases, right, and the bases are parallel. Alright, the other new property that we have is that the non-parallel sides are called legs. So we've seen this before with our right triangles, the legs, but now this is a little different. So our bases are parallel and the legs are the sides that are not parallel. Then we have a special type of trapezoid, which is called an isosceles trapezoid. Again, we've seen the word isosceles before. It was a triangle that had two congruent sides. So a trapezoid that is isosceles is a trapezoid with two congruent legs. So here's our regular trapezoid with our bases being parallel. If our legs are isosceles, then the legs are congruent, and that makes an isosceles trapezoid. Right? From an isosceles trapezoid, we get some interesting properties. Property one of an isosceles trapezoid has to do with the angles of the figure. If a trapezoid is isosceles, then each pair of the base angles is congruent. Right? So here we have an isosceles trapezoid. We can see that the bases are parallel, the legs are congruent. So the first property of the angle says that the base angles are congruent. So a base angle would be the angle that's touching the same base. So right here, these two bottom angles touching the bottom base, those would be congruent in an isosceles trapezoid. And the top angles, both of the angles that are touching the top base, are going to also be congruent. So that's a special property that only happens in isosceles trapezoids. Another property of isosceles trapezoids are that the diagonals are congruent. So again, we have our parallel bases, our congruent legs, and our diagonals will be congruent, similar to what we've seen in a rectangle and in a square. So those are the two properties of isosceles trapezoids. Then we have one more term to introduce, and that is a midsegment. Again, we've seen this word before. A midsegment was in our triangle unit, and we talked about the midsegment of a triangle was a line that connected the midpoint of two legs. It's the same idea of the midsegment in a trapezoid. A midsegment is going to be a line that connects the midpoint of the two legs. So if we have the midpoint of one leg connecting the midpoint of the other leg, then we call this line the midsegment. Right? And here's the formula to calculate the midsegment. Formula is going to be 1/2 of base 1 and base 2. Now we just label these whichever way we want. Base 1 can be the top base, base 2 can be the bottom base, or you could switch it. It really doesn't matter the order or which one you're naming which. So you're just finding the average of the two. And again, it has to be the midpoint. So if we have tick marks indicating that these are the midpoints of the legs, and we have a segment connecting the two. We call that the mid-segment. So let's do a few examples practicing these properties. Here we have a trapezoid. We know it's a trapezoid because we only have one set of parallel lines, and our tick marks show us that it's an isosceles trapezoid. We're given that one angle is 118. We know from the property of our angles of isosceles trapezoids that our base angles are congruent. So this angle is congruent to this angle, so therefore this is also 118. And since we are within parallel lines, this is still like a parallel line and a transversal, so our consecutive angles are still going to be supplementary and equal to 180. So 180 minus 118 is going to give us the remaining angle, which is 62. And again, the property of our trapezoid says that the base angles are congruent, so this angle is also 62 degrees. So with an isosceles trapezoid, we can very easily find all of the angles in our figure using our congruent base angles and our supplementary pairs of consecutive angles. Now, the supplementary pairs of consecutive angles only happen in between our parallel lines. So with our other figures, every single pair of consecutive angles was supplementary. This is not true in an isosceles trapezoid or in any trapezoid. Then last, they want us to find MN, which is the length of the midsegment. We know it's a midsegment because there are tick marks on either side of the trapezoid indicating that M is the midpoint and N is the midpoint. So we just need to apply our midsegment formula, which is 1/2 base 1 plus base 2. And it really doesn't matter which one we're calling base 1 and base 2. So 1/2 of 12 plus 28. When we add these two together, order of operations says that we need to add inside first. So 1/2 of 40, which is 20, so our mid-segment MN is 20 units long. Make sure that you have these properties and these examples copied in your notes for class tomorrow.